Hello everyone, once again welcome to PM Networking. Guys, today we are going to perform one more lab of EIGRP, right? So this is lab number 2, EIGRP. So this is my topology where I am going to perform some task. My task number 1 is configure the IP addressing on the routers as shown in the diagram, right? 123.45.67.x is the major network where X is the relevant subnet number. So major network is 123.45.67.x/30. So I had draw this topology in GNS3, right? And I had configured IP address. Okay, so you can see the major network is 123.45.67.x, right? Here I am using 67.0. Here I am using 67.4 between R1 and R4. Between R2 and R3 I am using network 67.8. Between R2 and R3 I am using network 67.12/30. So actually I am using /30. So what will be my first network? My first network will be 67.0. Second will be 67.4, 67.8, 67.12, 67.16, 67. Next, okay, so on. So here I am using this network, here I am using this network, here I am using this network, here I am using 12 network, right, this one. And between among R3, R4 and R5 I am using this network, right, 16/29, right? So for point to point I will use /30, and for multi-access network I will use /29. Okay, so this is my IP addressing. I had already configured IP address on the router. Let me show you very quickly. So this is my R1. Go to R1 and just wait, guys. So IP interface brief. Okay. Okay, so you can see, so IP interface brief exclude unassigned. This command will show you IP address. So on fast Ethernet 0/0 I am running IP 67.1. On 0/1 I am running 67.5, and these are my loopback. Okay, so actually I am running 5 loopback on R1, 5 loopback on R2 and 5 loopback on R5. Okay, here. So first task is you need to draw this topology in GNS3 and configure IP addressing, right, using subnetting. Okay, so let me check task number 2. So task number 1 is done. Use /30 on point-to-point subnet and /29 on multi-access segment. Okay. Now task number 2 is configure EIGRP on all routers, right? So you need to configure EIGRP on all routers. The autonomous system number will be 123. Autonomous system number will be 123, and every router should have 123.x.x.x/32 configured as router ID, right, where X is your router number. Okay, so here you need to configure EIGRP router ID 123.1.1.1, here 123.3.3.3.3, here 123.2.2.2, here 123.4.4.4, here 123.5.5.5, right? So okay, what I can do, I will create one more loopback on R1, on R3, right? So this IP address I will create one loopback. I will create one more loopback on R2 as well. I will create one more loopback on R4. I will create one more loopback on R5 as well, right? So this is highest IP address of loopback interface. So this IP address is elect as a router ID in EIGRP. Okay, so first of all let me show you all tasks that I am going to perform in this topology. Okay, so when I will configure EIGRP, so before configuring EIGRP, I will create one loopback as well, right? So task number 3 will be configure the routers such that they should use hello interval of 3 seconds and hold for 9 seconds. So you need to change hello timer and hold on timer on all the router, right? You need to set hello timer 3 seconds and hold on timer 9 seconds, okay, on all the interface. Now router should not receive any EIGRP routes from the routers that is more than 3 hop away. Okay, so you need to set maximum hop count as 3, right? You need to set maximum hop count 3. Okay, so in this topology I will set maximum hop count 3 on R1, R2, R3, R4 and R5. Fine. So next task will be task number 4. In the topology, R1 and R2 should receive all the loopback routes of R5 via R3 and R4, via R3 and R4 both as a best path. Okay, so guys, this task is whenever R1 and R2 will receive this loopback IP address which is running on router 5. So definitely R1 will receive this loopback from two sides, from R3 as well as from R4. So cost will be same, metric will be same from both sides. So definitely both sides will be best path, right? R1 will perform equal cost load balancing. In the same way, R2 will also receive this loopback from two sides, from this side as well as from this side, and they will calculate same metric from both sides. So definitely R1 and R2 will perform equal cost load balancing for this network. Both path will be best path. Okay, so perform this task, you don't need to configure anything. Okay, so as a best path. Now task number 5 is R5 should receive all the loopback routes of R1 and R2 via R3 and R4 as a best route. So definitely in the same way, R5 will receive this loopback from two sides, from here and from here with same metric. So both path will best path for R5, and R5 will receive this loopback via two side as well, from this side and from this side. So from both side metric will be same, so both path will be best path. So to perform this task also, you don't need to configure anything. Now task number 6. Now ensure that R1 and R2 should receive each other routes and routes of R5 via R3 as a best route. Okay, so question is, task is, whenever R1 will receive this prefix or this prefix, right, this path will best path, this path will best path, and this path will work as a backup path. So what we need to do, we will increase the delay or we can decrease the bandwidth of this interface, right? If I will increase the delay of this interface, then definitely R1 will calculate different metric on this interface. So this path will become backup path. Okay, so this path will become backup path. In the same way for R2, I will increase the delay of this interface. Okay, so task number 6 is easy. To perform this task, you are allowed to alter only the interface characteristics. So you are allowed to change bandwidth and delay. Now task number 6 is R1 and R2, R1 and R3, not R3, R2. Here is, okay, R3 should receive each other. So this is R2, this is R2, not R3, this is R2. R1 and R2 should receive each other routers specific via R3, and they should receive a summary of /16 via R4. Okay, so actually R1 will receive all prefix, all loopback of R2 via R3, and R1 will receive one summary address via R4. So we will advertise one summary address on this interface as well, In the same way, R2 will receive these prefix or via R3 as best path and via this path as summary. On via this path R2 will receive one summary address, so I will advertise one summary address on this interface. Okay, so guys, you will understand how to configure. So task number 6 is also easy, and task number 7 is consider R1 and R2 as a edge routers, right, connected to ISP. Now consider R1 and R2 is connected to ISP. This is my ISP. So R1 and R2 is a edge router. Okay. Now edge router originating a default routes from R1 and R2, but all the routers R3, R4 and R5 should use the default route of R1 as a primary route. Okay. So when these routers R3, R4, R5 will receive this prefix, right? They will receive this prefix 8.8.8.8 to reach ISP, default route towards ISP. Whenever this router will receive a default route, actually I will create one default route on R1 toward ISP. I will create one default route on R2 toward ISP. So when I will advertise that default route in EIGRP, so R3, R4 and R5 will receive the default route. So default route should be used via R1 as a primary link, right, and R2 as a backup link. So whenever R1 will goes down or this link will goes down, this router will reach to ISP via R2. So this path will become secondary path. Okay, so we will perform this task as well. Don't worry, I will show you how to perform. Okay, so should use the default route via R1 as primary. If R1 failed, then all router uses R2 default route. To verify your task, configure a loopback on ISP router. You can configure a loopback as well, right? You can configure a loopback here as well, right? Okay, so guys, first of all, I have already configured IP address on router. So let me show you. So IP interface brief exclude unassigned. So here I am running this IP address. So actually I need to configure one more loopback, right? That is 123.1.1.1. that will become router ID in EIGRP. Okay, so on R2 you can also see. So IP interface. So IP interface brief exclude unassigned. Here I am running this IP address, right? On R3, so IP interface brief exclude unassigned. I am not running any loopback on this router on R3. On R4 I am also not running any loopback. So IP interface brief exclude unassigned. Okay, on R5 I am running some loopback. So IP interface brief exclude unassigned. This is R5. Now you can see. Okay, so first task is configure EIGRP. This is my ISP router. Okay, so on R1 let me configure EIGRP. And guys, remember, I will not advertise WAN link, so I will not run network 0.0.0 command on R1 and R2. Okay, you can run 0.0.0 network command on R3, R4 and R5, but not on R1 and R2. So first of all, let me create one more loopback. That is interface loopback. Suppose 10 IP address is 123.1.1.1 255.255.255.255. Exit. After that, router EIGRP AS number 123 and network. So network is 123.45.67.0.0.255. This command will advertise these two interfaces in EIGRP, right? So let me advertise loopback network 1.0.0.0.255.255.255. So this command will advertise all loopback interface in EIGRP, right? So now guys, now you can change hello and delay time, hello and hold down time. So interface fast ethernet 0/0 IP hello interval EIGRP 123 is 3 seconds and IP hold on time for EIGRP 123 is 9 seconds, right? Now go to R2. Configuration of R1 is done. Configure terminal, interface, loopback 10, IP addresses 123.2.2.2, 255.255.255.255, router EIGRP 123, and network is on R2. I am advertising 123.45.67.0.0.255, and loopback is 2.0.0.0.0.255.255.255. Okay, now fine, let me show you the router ID. So IP protocol, you can see router ID of R2 is 123.2.2.2.2, right? So now guys, okay, so on R2 let me change hello time and hold on time. So interface fast ethernet 0/0, IP hello time for EIGRP 123 is 3 seconds, and IP hold on time for EIGRP 123 is 9 seconds. Okay, exit interface fast ethernet 0/1, IP hello time, hello interval for EIGRP 123 is 3 seconds, and IP hold on time for EIGRP 123 is 9 seconds. Okay, configuration of R2 is done. In the same way, on R1 I had changed hello time on fast ethernet 0/0. Let me change on 0/1 as well. Exit interface fast ethernet 0/1. Actually now I am on R1, you can see. Okay, so IP hello timer for EIGRP 123 is 3 seconds, and IP hold on time for EIGRP 123 is 9 seconds. Now let me configure R3. So go to R3, interface, loopback 10, IP addresses 123.3.3.3, 255.255.255.255, exit router EIGRP 123, and network we can run 0.0.0 network command here. Exit. Now interface fast ethernet 0/0, IP hello interval for EIGRP 123 is 3 seconds, and IP hold on time for EIGRP 123 is 9 seconds. Exit interface F0/1, IP hello time, hello interval for EIGRP 123 is 3 seconds, and IP hold on time for EIGRP 123 is 9 seconds. Exit interface F1/0, IP hello interval for EIGRP 123 is 3 seconds, IP hold on time for EIGRP 123 is 9 seconds, right? Now configuration of R3 is done. Let me show you the router ID. So IP protocol, so you can see the router ID of this router is 123.3.3.3. fine. Now let me configure R4. So interface loopback 10, IP addresses 123.4.4.4.4, 255.255.255.255, exit router EIGRP 123, and network is 0.0.0. Let me change hello time and hold on time on R4. So interface F0/0, IP hello interval for EIGRP 123 is 3 seconds, IP hold on time for EIGRP 123 is 9 seconds. Exit interface F0/1, IP hello time for EIGRP 123 is 3 seconds, IP hold on time for EIGRP 123 is 9 seconds. Exit interface F1/0, IP hello interval for EIGRP 123 is 3 seconds, and IP hold on time for EIGRP 123 is 9 seconds. Fine. Now let me configure R5. So IP protocol. Let me verify your router ID. So you can see router ID is this one. Let me show you the neighbor. So IP EIGRP neighbor, you can see. Now there are three neighbor, right? R3, R1 and R2. Now let me configure R5. So go to R5, configure terminal, interface, loopback 10, IP address is 123.5.5.5, 255.255.255.255. Okay, so IP address is 255.255.255, exit. Now router EIGRP 123 and network is 0.0.0, exit. Interface fast Ethernet 0/0, IP hello interval for EIGRP 123 is 3 seconds, and IP hold on time for EIGRP 123 is 9 seconds. Okay, now guys, on R5 you can verify router ID. So IP protocol, so router ID is this one. Let me show you the neighbor table. So IP EIGRP neighbor, so there are two neighbor, R3 and R4. Let me show you the routing table. So IP root EIGRP, so R1 is receiving these all prefix 1.1.1.1.1.1, 1.2.0, 1.1.3.0, 1.1.4.0, 2.1.1.0, 2.1.2.0, all loop back which I am running on R1 and R2, right? So R5 is receiving all prefixes, right? In the same way, R1 is also receiving all the loop back which I am running on R5. So IP root EIGRP, you can see, right? Here is 5.5.5, and R1 is performing equal cost load balancing. Yes, R1 is performing equal cost load balancing, because here is two path via, one is 67.6 and 67.2. that means here I am running 67. Here is 67.1 on this interface, 2 is, so one path is via R3 and one path is 67.4 is network ID. So I am running 67.5 over here and 67.6 over here. So other path is this one. So R1 is performing load balancing for this loopback. Yes, right. Now guys, let me show you how many tasks is completed. So task number 1 is completed, task number 2 is completed, task number 3 is completed, task number 4 is completed, right? Actually in the topology, R1 and R2 should receive all the loopback routes of R5 via R3 and R4 as a best path, right? So definitely R1 is receiving 5.5.5 via two side and both are best path. So that's why this router installed both path in their routing table. You can see the topology table of R1 as well. So IP EIGRP topology. So here is 5.5, where is 5.5 here, right? So for this network you can see there is two path and metric from both sides is same. Metric from both sides is same. RD from both sides is same. Okay. Now this task is also completed. Task number 3, task number 4. Now task number 5. R5 should receive all the loopback routes of R1 and R2 via R3 and R4. Via R3 and R4 as a best path. So let me verify it. Go to R5. So IP route. So IP EIGRP topology table. Okay. So you can see here is 1.1.1 network, right? So R1 is receiving from how many side? From two side, and metric is same, so both path is best path. So R5 will install both path in their routing table. So IP route EIGRP. So you can see how many paths are there? Two paths. First one is via 67.18 and second one is 67.17, right? So actually 67.17 I am running on this interface. Actually network is 67.16. So here I am running 67.17, here I am running 67.18 IP address, and here I am running 67.19. So definitely R1 is receiving. In the routing table of R5, there is two paths for this network, for this network, via 67.17 and via 67.18. You can verify it. Okay. You can see 1.1 via 67.18 via 67.17. In the same way for this loopback, which I am running on router 2, there is two paths. Both are best path via 67.18 and via 67.17. So task number 6 is also completed. Fine. Task number 5, sorry. Now task number 6 is, now ensure that R1 and R2 should receive each other routes, right? So definitely R1 and R2 is receiving. Actually R2, go to R1 is receiving the loopback of R2, so IP route. So yes, it's receiving the loopback of R2 via two paths, via R3 and via R4. Both are best path. Now question is, ensure R1 and R2 receive all each other routes and loopback of R5 via R3 as best path and R4 as a backup path, right? Now question is, whenever R1 will receive these prefix or these prefix, right? R1 will receive via R3 as best path and via R4 as backup path. So we need to change the delay of this interface, right? So go to R1 guys, go to R1, and after that configure terminal. Interface is interface fast Ethernet 0/1. Let me change the delay. Delay is, suppose delay is 11. Okay, by default delay is 10. I have increased delay by 1, right? So interface fast Ethernet 0/1. So interface fast Ethernet 0/1. You can see the delay is 1110 now, right? And delay of 0/0 is 100, right? So now let me show you the routing table of R1. So IP route. Now you can see there is only one path, right? There is only one path via 67.2. So 67.2, I am running 67.2 IP address on R3 interface over here on this interface, right? So now R1 is receiving this prefix via this path, right? This path is best path. But if you will check topology table, so you will get two paths. So IP EIGRP topology. So for 5 network or for 2 network, you can see there is two paths, but this time metric is different. This time metric is different. R1 is receiving via 67.2, is metric is 158720, and via 67.6 this router is receiving metric 158976. So this is list metric, so this path will become best path, right? In the same way for R2 as well, for R2 loopback as well, this router is receiving for R2. So here is 2 network, right? This is, so definitely R1 is receiving this prefix from 2 side, and this router is calculating different metric from both sides. So via R3 is best path. So IP route. Okay, You can see here there is only one path for two network. There is only one path via R2, but whenever R via R3. So, but whenever R3 will goes down, there is one backup path as well. So, IP EIGRP topology. So, there is one backup path via R4. So, whenever R3 will goes down, this path will become best path. They will install this path in their routing table. So, IP route. So, now best R1 is calculating best path via R3. So, your task number 6 is completed. Best path and R4 as a backup path, right? R4. To perform this task, you are allowed to alter, okay, you are allowed to change the delay. Now, when R2 will receive R1 prefix, when R2 will receive these prefix and these prefix, they will receive via R3 as best path and via R4 as backup path. So now this time we need to change the delay of this interface, right? This interface, receiving interface. So if I will increase the delay, of F0/0 on R2, so now you can see, so IP route. Now R2 is receiving, okay, go to R2, this is R2, so IP route. Now R2 is receiving via two side and both path is best path. In the same way, R2 is receiving this network loopback of routers 5 from two side and both are best path. So let me manipulate it. R2 should receive all prefixes of R1 and R5 via R3 as best path and via R4 as backup path. So interface F0/0, and let me increase the delay is 11. Now, so IP route. Now you can see there is only one path. There is only one path for one network. There is only one path for 5 network, but there is two path in topology table. So IP EIGRP topology. There is one backup path as well. You can see, right? But metric is different. So via R4 is a backup path and via R3 is a best path. Fine. So this task is completed. Task number 6. Now task number 6. This is task number 7. This is task number 7. Okay. This is task number 7. Now R1 and R3 should receive routers 5 routes, especially via R4, and then, okay, now this time R1 and R2 receive R5 routes, specifically via R4. Okay, now and they should receive a summary of /16 via R3. Okay, so now this path will become best path via R4, and via R3 they will receive a summary route. Okay, so guys, to perform this task, let me increase the delay of this interface, then definitely this path will become best path via R4. If I will increase the delay of this interface, so this path will become best path, and this R2 will receive a summary prefix of this and this prefix from this prefix of this prefix and this prefix via R4 as a best path, and a summary route via R3. Okay, so first of all, let me increase the delay of 0/0. Interface F0/0, delay is 12. Okay, now go to R2, configure terminal, interface fast Ethernet 0/1, and delay is 12. Okay, now you can see, so IP route EIGRP, R1 is receiving this prefix, this loopback of R1 via 67.1. so I am on R3 now, right? So go to R2, let me run so IP route command. So IP route EIGRP, here is So now this time R2 is receiving these prefix 1.1.1.0, 1.1.2.0 via R4 because 67.10 is IP address of this interface. IP address of 10 is 8, 9, 10 of this interface. So R2 is receiving via R3. R2 is receiving via R3. R2 is receiving via R3. Why via R3? So task is they should receive via R4. They should receive via R4. So I had increased the delay, but again this router is receiving. So IP EIGRP topology. Let me check topology table. So here is this prefix, right? So via R3 this router is calculating metric 158720, and via this path metric is this one. So interface fast Ethernet 0/1. Let me check the delay of this interface. Okay, so delay of this interface is again 100. So where I had change delay. Okay, now go to R1. Let me change the delay of this interface. Interface F0/1 and delay is 12. Okay, now so IP root EIGRP. So IP root EIGRP. Now this router is performing load balancing. Just wait guys, let me troubleshoot it. So interface fast Ethernet 0/0. So here delay is 120. Okay, so earlier I had changed the delay of this interface. So interface F0/0 and delay is 11. Okay, now so IP root EIGRP. Now R1 is receiving this prefix via R4 as a best path. This prefix via R4 as a best path. In the same way, let me show you the routing table of R1. So IP root. So 2.2.2 via R4 as a best path, via R3 as a best path, right? So interface F0/0 delay is 100, and so interface fast Ethernet 0/1 delay is 11 time. So let me increase the delay of 0/0. Interface fast Ethernet 0/0 and delay is 12. Now definitely R1 will receive. So IP root via R4. Now 2.2 and you can see via 67.6. 67.6 is R4. So now R1 is receiving this network via R4 and this network via R4. So there is one backup path via R3. So IP EIGRP topology, right? There is one backup path via R3. Now guys, task number 7. They should receive a summary of /16 via R3. Okay, so on via R3 they should receive a summary address, right? So go to R3 to perform this task. Go to R3, configure terminal. Now interface fast Ethernet 0/0, IP summary address. So summary address for this network will be 5.1.0.0. Actually you can calculate summary as well, right? How to calculate? So where is change in third octet? So binary of 1 is 0 0 0 0 4 times 5 6 7 8 1. Binary of 2 is 1 0, binary of 3 is 1 1, binary of 4 is 0 0, binary of 5 is 1 0 1, right, and 0 0. So you will get here, right? So 16 17 18 19 20 21 21, so slash will be 21, right, and summary address will be 5.1.0.0, right. So this will become summary address. Okay, let me advertise it. /1, what will be the subnet mask? /1 subnet mask will be 255 dot 255 dot 255 dot 255 dot 255 dot 21. So for /21 subnet mask will be 248.0. After that 255 summary address, wait guys, for EIGRP 123 is 5.1.0.0. subnet mask will be 255.255.248.0, right. Now guys, you can see the routing table of R1. R1 is receiving one summary address, so IP root EIGRP. So here is summary address. So summary address, R1 is receiving summary address via R3 and particular prefixes via R4. In the same way, go to R4 as well. Go to R4 as well and configure terminal. Now interface, no, on R3. On R3, R2 will receive one summary address via R3. So R2 is connected to R3 on which interface? On 0/1. So interface F0/1. IP summary address for EIGRP 123 is 5.1.0.0. subnet mask will be 255.255.248.0, right. Now you can see the routing table of R2. So go to R2. So IP root EIGRP. So R2 is receiving one summary address via R3 and particular prefixes via R4, right. So now this task is completed. R1 and R3 should receive R5 routes via R4 and they should receive a summary address of /16 via R3. Okay, so here you need to advertise via /16. So okay, let me change it. Go to configure terminal, interface F0/0, no IP summary address EIGRP 123 and 5.1.0.0 255.255.248.0, right. And let me advertise again. Summary address for EIGRP 123 is 5.1.0.0. subnet mask will be 255.255.0.0. Now this time R1 will receive via a summary route via R3 with /16. In the same way, let me remove summary address via summary address by /21 via R3. So no IP summary address EIGRP 123 and address is 5.1.0.0 255.255.248.0, no, and IP summary address for EIGRP 123 is 5.1.0.0. subnet mask is 255.255.0.0. Okay, now you can, no need to run this command on R2. Actually I had run this command on R2, so you need to run this command on R3. Okay, so let me remove it. Interface F0/0, no, exit, interface F0/1, no. Okay, now go to R3 and interface fast Ethernet 0/0, IP summary address for EIGRP 123 and summary address is 5.1.0.0, subnet mask is 255.255.0.0, exit. Now interface fast Ethernet 0/1, IP summary address for EIGRP 123 is 5.1.0.0, subnet mask is 255.255.0.0. Now everything is fine. Now go to R2 and you can see show IP root EIGRP. Now R2 is receiving one summary address with /16 via R3 and particular prefixes via R4, right? So now this task is completed, task number 6. Now let me perform task number 8. This was task number 7, this is task number 8. Consider R1 and R2 as edge router. Okay, now let me configure ISP. Guys, let me configure ISP router. So here is ISP router. So go to configure terminal mode, interface F0/0, IP address. Suppose here I am running network 11.1.1.0. So I will configure 2 on this interface, 255.255.255.0, exit, and interface fast Ethernet 0/1. Here I am running IP address is 12.1.1.2 okay, exit, interface loopback 1 and IP address is 8.8.8.8. subnet mask is 255.255.255.255. okay, so actually guys, here I am running which network? Here I am running 11.1.1.0. here I am running 12.1.1.0. okay, so go to R1, configure terminal, interface F1/0, no shutdown, IP address is 11.1.1.1, 255.255.255.0, exit, go to R2, configure terminal, interface F1/0, no shutdown, IP address is 12.1.1.1, 255.255.255.0. let me ping 8.8.8. will it ping 8.8.8.8? no. So we need to run one default route towards ISP on R1 and R2. So first of all, let me run default route on R1, IP root 0.0.0, subnet mask is 0.0.0, and next hop IP address is 11.1.1.2. okay, now ping 8.8.8.8. so will it ping? Yes, definitely. No. Why I am not able to ping 8.8.8? it should ping. So IP interface brief exclude unassign. So here is 11.1.1.1. Let me ping 11.2, ping 11.1.1.2. So I am not able to ping 11.2. Let me check from ISP end. So IP interface brief exclude unassigned. So interface is down. So let me up. Now interface F0/0, no shutdown. Exit interface fast Ethernet 0/1, no shutdown. Exit. Now go to R1. Now will it ping? So yes, will it ping 8.8.8? So yes, now I am able to ping 8.8.8 from this side. From R2 am I able to ping? Configure terminal IP route 0.0.0, 0.0.0, and next hop is 12.1.1.2. okay, ping 8.8.8.8. So yes, I am able to ping, but I am not able to ping from R3, R4 and R5. Actually ping, and if I will say source fast Ethernet 0/0, so yes, I am not able to ping. So let me configure PAT over here. So we need to configure PAT or NAT. Okay. So go to R1 first and let me configure NAT or PAT. So to configure PAT, we need to create one access list 10 permit any. Okay. Now IP NAT inside source will be list access list 10, and after that translate the source list 10 into fast Ethernet into interface fast Ethernet 1/0, right? 1/0. Okay. Now if I will ping 8.8.8 from source for F0/0, will it ping? No. So go to interface. Wait guys, this is NAT. Let me configure PAT. No. You need to write one more key, that is overload. After that interface fast Ethernet 1/0 IP NAT outside. Exit interface F0/0 IP NAT inside. Exit interface F0/1 IP NAT inside. Okay. Now definitely I am able to ping 8.8.8 and source is fast Ethernet 0/0. Now I am able to ping. Yes. So go to R2. The same way, let me configure PAT on R2. So let me create one access list number 10 permit any, right? IP NAT inside and source will be access list 10, and translate access list 10 into interface fast Ethernet 1/0 and overload. Now interface F1/0 IP NAT outside. Exit interface fast Ethernet 0/0 IP NAT inside. Exit interface fast Ethernet 0/1 IP NAT inside. Guys, am I able to ping 8.8.8 from fast Ethernet source fast Ethernet 0/0? Yes, I am able to ping. But guys, am I able to ping from R3? Is R3 is reachable to ISP? No, right? So what we need to do over here is we can run one default route on R3 as well. So we need to run default route on R4, R5 as well. So instead of doing this, I will advertise the default route which I am running on R1. So go to configure terminal, router, EIGRP 123 and redistribute it. Redistribute static. Actually in routing table of R1 you can see there is one static entry. So IP route, there is one static entry, this one. So I am going to redistribute this static route in EIGRP. Okay, so configure terminal, router, EIGRP 123 and redistribute static. Okay, now go to R3. Is there one default route? So IP route EIGRP. So yes, there is one default route. Now if I will ping 8.8.8 from R3, ping 8.8.8.8 from R3. So yes, I am able to ping in the same way. I can ping from R5 as well. Ping 8.8.8.8. Now all traffic is going via R1, right? In the same way, let me redistribute R2 default route in EIGRP as well. So actually now if you will see the routing table of R5, so IP route, there is no backup path of this default route. Yes, there is one backup path, but all traffic is going via R1, right? Via R1. Actually there is two path. You can see there is two path in routing table, via this one and via this one, but from R4 there is only one path, via R3 there is only one path, right? So let me redistribute default route on R2 as well. So guys, go to R2 and configure terminal, router, EIGRP 123, redistribute static. Now go to R3 and now you can see, so IP route EIGRP. Now there is only one path. Just wait for some time. Just wait. There is only one path. Clear. IP EIGRP never. Okay, and so IP route EIGRP. So IP EIGRP topology. For default route there is only one path. So go to R2. Okay, so here the router EIGRP 123 and redistribute static. Now let me show you the routing table of R3. So IP route. So IP route on R4. On R4 there is how many paths? There is two paths, via 67.13 and via 67.5. There is two paths now, but why I am not getting two paths in R3 routing table? So IP route. So interface fast Ethernet 0/0. So bandwidth delay is 100. So interface 0/1 delays 120. Okay, let me change the delay. Interface fast Ethernet 0/1 and delay is 100. Delay no, delay is 10. Now definitely R3 will receive default route from two sides. So IP route EIGRP, you can see there is two paths, right? Now there is backup path. Yes. Now my task is R3, R4 and R5 should use a default route via R1 as primary routes. If R1 will fail, then R2 will become best path. Okay. So guys, what I can do, I can increase the delay of this interface and I can increase the delay of this interface, right? If I will increase the delay of this interface, right, of this interface, now R3 will receive one default route on this interface and on this interface. So definitely R3 will calculate least metric on this interface, so they will install this prefix as best path, right? And we have one more option as well. We can just see what we can do. We have one more option, and that option is best. So go to R1 first of all. Go to R1 and run router EIGRP 123 no redistribute static. In the same way, let me run this command on R2 as well. No redistribute EIGRP. Now I am going to redistribute on R1 first. Redistribute router EIGRP 123. Redistribute EIGRP 123 and metric. Now this time I will assign the components of metric like bandwidth, delay. So metric, so bandwidth is, suppose bandwidth is 100 Mbps. 1 2 3, this is 100 Mbps. Okay, so now delay is, suppose delay is 110. Okay, and reliability is 255. Okay, load is 100. Okay, MTU is 1500. Okay, fine. Now here I am redistribute EIGRP, no redistribute static. Here redistribute static. Metric is 100 Mbps, delay is 10, and on R2 I will increase the delay while advertising. Okay, now you can see the routing table of R3. So IP route, there is only one path for default route, right, in topology table. So IP EIGRP topology, there is only one path. Where is default route? Yes, this one. There is only one path. Fine. Now guys, go to R2 and redistribute static metric. Bandwidth is again 100. 1 2 3, 100 Mbps. After that delay. So here I am assigning delay 11. Okay, and rest components are same. 255, 100. MTU is 1500. Okay, now let me show you the routing table of R3. So IP route EIGRP. So there is only one path for default route. So IP EIGRP topology. You can see there is two path. There is two path. Now this path via R1 is a best path, and this path is a secondary path, backup path. In the same way, on R4 also you will get two paths. So IP EIGRP topology. So here you are getting two paths. This path is best path and this path is backup path, right? So IP route, there is only one path via R1, which is best path. Okay, so the task is completed all task is completed, guys. This is very simple task, right? Now if you are able to configure this task, many of my subscriber was not able to configure, so that's why they were requesting me to make one video on it. So that's why I had completed this. I configured this network. Okay, so now if you are able to configure, please hit on like button. If you haven't subscribed my channel, please subscribe this channel. That's all for today. If you have any query, any concern, please let me know in comment. We will meet in next video. Till then, stay safe. Bye bye. Thanks for watching.